two projects. In this video, we are going to explain about the project, which is a reliable and robust deep learning model for effective recyclable waste classification. Before getting into the execution, first let us understand what is the project about. When we think about the rapid growth of cities and also industries around the world, it is clear that our demand for natural resources has also exploded. Along with this growth, unfortunately, comes a massive increase in the waste generation. So nowadays, waste is being produced a lot. So this isn't just a small problem. Either urban areas are especially struggling with mounting waste filling up with landfills and also ending up with incinerators. So these traditional disposal methods aren't just unsightly, they are also hazardous. For instance, landfills release harmful chemicals into nearby soil and water resources, and also incinerators they contribute to air pollution. Now think about household waste. Not all of it breaks down easily. Certain items like plastic that are non-degradable can linger in the environment for decades, harming ecosystem. Marine life in particular suffers when plastics reach the ocean, as animals can mistake them for food. They think that it is food and they consume it. It leads to devastating consequences of the entire marine life ecosystem. So, seeing the urgency of the situation, organizations like Environmental Protection Agency have been pushing for recycling as a sustainable solution to help curb waste. But the issues like 2016, global waste production was already at 2.01 billion tons and it is expected to grow even more, reaching around 2.59 billion tons by 2030. Clearly, while recycling is vital, it is alone isn't enough to handle the ever growing waste load. This is why we need more efficient and innovative waste management solutions that can tackle the problem head on, keeping our cities and ecosystems safer for future. When it comes to recycling, it seems like the perfect solution for reducing the waste and also helping the environment, right? But there is a big catch. Traditional waste storing methods are still far from ideal. They are often slow, expensive, and also require a lot of manual labor. Imagine people having to sort through piles of waste every day. It's time consuming and can be very inefficient. And to make matters worse, a lot of people aren't fully aware of how to categorize waste correctly. This lack of awareness can lead to items being placed in the wrong bins, which disrupts the recycling process and also reduces its effectiveness. So, where do we go from here? This is where a deep learning automation comes into the picture. By using AI powered systems, we can actually automate the waste classification process. These systems can be trained to identify and sort different type of waste with impressive accuracy, which could save a lot of time and also money. Automated waste classification through deep learning not only boosts operational efficiency but also reduces the need for manual sorting, which can make the entire recycling process smoother and more effective. This kind of innovation holds huge potential for making recycling more scalable and accessible, one step closer to truly sustainable waste management. So now let's imagine having a system that can automatically recognize and sort different types of recyclable waste without any manual effort. That's exactly what RWC Net is designed to do. It's the proposed model. It is a deep learning based model developed to take over the heavy lifting in the waste sorting. And it is targeted at making recycling much more efficient and effective. So, what does this RWC net combines? It combines two powerful architectures that are DenseNet 201 and MobileNet 2. Each of these models is exceptional at analyzing and also extracting features from the images. So when they're used together, they become even better at classifying, identifying waste categories. This setup allows RWC Net to recognize six distinct types of waste that are nothing but cardboard, glass, metal, paper, plastic, and trash. So the system can quickly and accurately distinguish between these categories, meaning we don't have to rely as much on people manually sorting through materials. What's exciting here is that RWC Net makes automated waste sorting not just feasible but highly reliable. This kind of technology has potential to make a real difference in how we handle waste and protect the environment. And this RWC Net It is designed to improve the waste sorting by addressing class imbalance in the data using customized data augmentation techniques. It enhances the model's ability to generalize by applying transformations like resizing, flipping, augmentation, converting images to normal sizes. So, this ensures consistent input data and optimal learning conditions. Overall, the system improves the efficiency and accuracy of automated recycling, helping to promote sustainable waste management practices. To further improve the performance, as an extension, we have added some powerful tools to improve both the accuracy and usability of the waste classification. So we have integrated exception and NASNet algorithms, and even we have created an ensemble algorithm combining both of these algorithms. So this way we get a more robust analysis and higher classification accuracy when sort waste. Furthermore, we have also extended our project to detection, that is to real-time detection. We have used YOLO algorithm, that is you only look once, which is designed for real-time object detection. In this case, they help to detect any irregularities in the waste classification process. So if something is unusual comes up, the system can identify quickly and ensures more reliable sorting. So you only look once algorithm is used for detection process, exception and NASNet algorithm is used for classifying the objects. Moving on, to develop the front end, we have used Flask framework. So where users can test the system firsthand. So this interface allows also includes user authentication for secure access, making it more accessible and also user friendly. Altogether, these upgrades can make the system more accurate, easy to use, and potentially ready for broader adoption, which is a big step forward for effective waste management. Moving on to the implementation of the project. So we have followed the steps mentioned in the flow of work to implement the project. As we have done classification and detection, we have followed different set of steps. So these are the steps followed for classification and these are the steps followed for detection. So let's understand them first what they are. So first what we have done is we begin by importing essential libraries needed for data handling and image processing and also model building. The next step involves loading and analyzing the dataset, ensuring we understand the structure and categories within the garbage classification data. And then what we do is we apply various transformations that are applied to the images to increase the dataset diversity and improve the model performance. And we adjust pixel values to a standard scale, that is rescaling. And we distort the images to simulate different perspectives, that is shear transformation. And we zoom images to alter the image focus, and we apply horizontal flip that mirrors the images, adding variety. Coming to reshaping, so we resize the images to standard dimensions for model consistency. Coming to the next step, that is function for calculating the recall, precision, and FN score. So this function helps us to measure the model's performance, allowing us to track its accuracy in identifying each class correctly. Coming to defining early stopping, so to avoid overfitting or underfitting, we use early stopping, which halts training if the model's performance on validation data stops improving. Coming to calling the model, we select and initialize the classification model, which will be trained to distinguish between waste categories. And coming to building and training the model is configured with layers suited for image classification and then trained on our augmented dataset to learn the features of each waste type. The last step of classification is the model achieving the highest accuracy is saved for the future use in identifying classification, that is, in classifying the waste categories. Moving on to the detection part, similar to classification, we import libraries for data handling and image detection models. Then we explore the dataset where we load the image from the dataset and we visualize the dataset. We display the images to visually inspect the dataset's quality and also the content. Coming to image processing, here we convert images into blob objects. So this step prepares the images format for YOLO detection models. And then we define the class labels. So here labels are assigned to each waste type. For example, cardboard image will be assigned with the cardboard label. Similarly, metal, bottle, etc. Moving on to declaring the bounding boxes. So this specifies the region in the image where objects are located. Then we convert array to NumPy array. So here images are converted from the array format to the NumPy array. This ensures the compatibility for further processing. Coming to loading the pre-trained models here, network layers are loaded to initialize the YOLO models and identifies the layers responsible for prediction key for YOLO accuracy. Moving on for further image processing, we append the image and annotation files. This is linking images with the corresponding labels. And we convert images which are in the BGR format to RGB color format. And we create mask, we resize the image. So here we standardize the image size for consistent model input. And then we apply data augmentation. So here we add additional transformations, help the model to generalize better, where we randomize the image, rotate, and also transform. The images create diverse training examples. So by doing all this, diverse images are being created. Then, then we install all the YOLO required libraries for seamless detection processing. And then YOLO models are initialized to process the data with object detection. Then YOLO family is used to build detection models. For example, we have used YOLO V5X6, YOLO V8, YOLO V9 versions, enhanced detection with progressively refined accuracy. Coming to training the model, the YOLO models are trained to recognize and detect specific waste types, improving their detection capabilities. And the best performing YOLO model is saved for the future use for detecting the waste category. Moving on to the front end part, so we have used Flask framework to develop the front end. So the user interface is built with the Flask featuring a registration and login. Here we have used SQLite for database purpose. So moving on to the next part where the front end is designed to leverage the trained models for both waste classification and also detection. In the front end, we will be classifying the waste categories as well as we will be detecting the objects. We will be detecting the waste category in the particular image. And users, they will be uploading the images in the front end, which can be processed for both the classification purpose and also the detection purpose. So the image will be processed at the back end. So here, images that will be processed at the back end for optimal performance. And then the pre-trained models will be used to classify and detect the items within the image, delivering accurate waste sorting. And final outcome will be displayed through front end. So the results, including waste category and detection details, are presented through the front end, providing an intuitive experience for users to interact with the system. So this is how we have executed the project. Moving on to the classification. These are the algorithms used to classify the waste categories. These three are the extension models, and this is the proposed model. And to detect objects, that is to detect the waste objects, we have used YOLO V5X6, YOLO V8, and YOLO V9. So all these are the extension concepts. Moving on to the requirements, we need basic requirements which are hardware and software. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now let us execute the project. To execute, we need to open the code folder which contains source code files. So let us open the code folder of the project. These are the source code files in the code folder of the project. Let us understand them. How will they be used in the project? So here in the garbage classification, here we have the data set. So here we have total 6 different classes, that is cardboard images, glass images, metal, paper, plastic, and trash. Let's open the cardboard images. So these are the cardboard images used to train the model to classify the images as cardboard. Similarly, here we have glass images. Here we have metal images. We do have paper. We have plastic. We do have trash images. So these are the trash images. Let's get back. We will be using these images to train the models. Let's get back. Here in the output folder, they are saved into train and validation folder. So the images in the garbage folder are being stored as train and validation, wherein train folder will be used to train the models. Validation folder is used to evaluate the models. So in train, we'll be having all the 6 categories, and also in the validation folder, we'll be having all the 6 categories. Let's get back. Here in the sample folder, we have two subfolders. One is classification and the other one is detection. So the images in the classification folder are used to classify the images of waste category in the front end. We will be using the test cases to detect that is to classify the waste category. And here in the detection folder, we have the images. So these images are used to detect the waste category, waste object. Let's get back. Coming to static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. Coming to the templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. This is the model file. Here we have model files, multiple model files that are .hy files. So these files contain the algorithm information that will be loaded into the project code during runtime. In best.pt file, we have the detection algorithm. And here in the dense, ensemble, mobile, nasnet, exception.hy, these are the model informations that are for classifying the waste category. And here we have two notebook files. So these are the two notebook files, which are the Jupyter notebook files, which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have signup.dv file. This file is a database file which is used to store the user information. Here in the YOLO V5, YOLO V8, and YOLO V9, we have the data sets. So let's open the YOLO V5. So here we have test and train. Let's open the train folder. Here we have two more subfolders. One is labels and images. Let us open the images. So here we have total 800 images. So these 800 images are used to train the detection models that are YOLO models to detect the waste category. Let's get back. Let's open the labels folder. So these are the files containing annotations or the labels for the objects in the corresponding images folder. So here, each label file, it corresponds to an image file in the image folder. So for example, this first image, that is the first label file, it corresponds to the first image in the image folder. It corresponds to this image, which provides object locations and classes within the image. Similarly, for the second image, we have object locations in the second label file. Accordingly, for all the 800 images in the images folder, we have total 800 annotation files. For example, let's open one file. So these label files, they follow the YOLO format. Here, this line represents a detected object. So this line specifies object class index. So this is the object class index followed by its bounding box coordinates. 4 is one type of waste category, and these are the bounding box coordinates detected in the image. Let's close this. Similarly, we will be having in all the 800 label files. Let's get back. Coming to test folder, here also we'll be having the images and labels. We will be using these for evaluating the models. Let's get back. Here we do have same images in the YOLO V8 and also in the YOLO V9 folders, but they have annotated differently because each YOLO version, they require its own specific type of annotations for training and testing the models effectively. Having separate folders keeps the dataset organized, ensuring that each YOLO version receives the correct annotation it needs to function properly. So the images which are in the YOLO V5, V8, and V9, they are used to train the models to detect the waste category, and the images which are in the garbage folder, that is garbage classification folder, these are used to train the algorithm to classify the waste category. So now let's copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. It has been opened. Now use the command cd followed by the space, paste the copied path. Now click on enter. So this will change current directory to the code folders path. So by using the cd command, current directory is changed to the code folders path. Now give the command python space app.py to compile the app.py file. Now click on enter. So this command, it will execute the Python script and perform runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. Just wait for a while, it's being loaded. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. So I've copied the link. Copy the link. Now open any web browser. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. We need to register first, so click on that and enter all the registration details if you are registering newly. I have already registered, so I'll directly log in. Click on login, give your username and the password, click on submit. We have logged in successfully and we are redirected to classification page of the project. We'll be doing both the detection and classification. So first we will be doing classification. So click on classification. So here you can see a choose file button, right? We need to click on that for uploading the images. So let's click on that. Here in the sample folder, we have the test cases. So let's open it. We have two subfolders. One is classification and detection. As we're doing classification, let us open classification. So these are the 6 different classes that we will be classifying now. So let's try with the cardboard. So let's open that. Let us upload this image. Open it. Now upload it. So image is being processed at the backend and then we got the prediction. This is the uploaded image and here it has correctly predicted as waste type is cardboard. So it has correctly predicted it as cardboard. Let us upload some more. Now let's upload this image. Upload it. And here we got the prediction. It has correctly predicted as cardboard. Let's get back. Click on choose file. Now let's upload this one. So here let's see what waste will be predicted. Here it has been predicted as cardboard. So cardboard class is being correctly predicted. Now we will check with the other classes. Click on choose file. Let's check with glass. So let us upload this one. So this is the image uploaded and here we got the correct prediction as glass. Let us upload one more image of glass and see whether it will correctly predict or not. So here let us upload this image. Click on open and now click on upload. And here we got the prediction as predicted type is glass. We got correct prediction, right? Let us upload one more image of glass. Let's upload this image. Click on upload. And here we got the prediction. So it has correctly classified as glass. You can observe, right? Let's get back. Now we will try with the other class. So get back. We'll try with the metal. So let's try to upload this one. Here, this is the uploaded one, and here it has correctly predicted as metal. Let's upload some more images of metal. So now we will upload this one. Click on open. And here, this is the uploaded image, and here it has correctly predicted as metal. So this image, this waste category is metal. Let's try using some more images. So now we will be predicting using this one. So this is the image that we have uploaded and here we got the prediction as metal. So this is the uploaded image and this is the metal. So application has also correctly predicted as metal. Let us try with some more cases. We'll try with the paper. So these are the images. So let's upload this one. It has also correctly predicted as paper. So this is the waste image that we have uploaded, waste object, and that is paper. Let's try using some more images of paper. So let us upload this one. So this is the image of the paper that we have uploaded and the application has also correctly predicted as paper. Now let's try with the other case, that is plastic. Now let us upload this one. So this is the image that we have uploaded and here it has correctly predicted as plastic. Let's try one more image of plastic. So now let us upload this image. and click on open. And here it has been uploaded, and here we got the prediction as plastic. Now let's try with the last case of the waste materials. Let's get back. Let's try with the trash images. So these are the trash images. Let's upload the last one. Click on upload. And here this is the uploaded image, and here we got the correct prediction as trash. So it has correctly predicted trash. Let us upload the last image for the classification. So now let's upload this one. Now click on upload. So here if you observe, the application is correctly sorting, that is correctly classifying the objects. So here also it has correctly predicted as waste type is trash. So this is the classification part. Now let's check with the detection. So click on detection. Before that, let us understand what is the difference between classification and detection. So in classification, when we have uploaded any specific image, let us assume we are uploading this image, click on upload. So classification is looking at the picture and deciding what it is. For example, you see a picture of cat and you say that it's a cat. It's just about figuring out what the whole image is. So we have uploaded this image and here we got the classification as trash. Now we will see what is detection. So for that, click on choose file. So now let us upload this image, click on open. It has been loaded. Now click on upload and detect. Here, if you observe, cardboard has been detected in the image. It has drawn bounding box around the cardboard and it has labeled it as cardboard with the 0.95 probability score. Probability score is nothing but it is how accurate the detection is. Here, coming to the detection, what is detection? Detection is about not only figuring out what is the image, what in the image, but also finding out where it is. So here, coming to the classification, it has only classified what is that object. Here coming to the detection, it is classifying the object and also it is locating where that object is. So it is drawing bounding box around the object. Let's get back. Let's try using some more images. So now let us upload this image. And here cardboard has been detected. Now we will try detecting other classes. So let us upload this one. So here it has correctly classified as glass with a 0.87 probability score. Let's try uploading some more images. So now let us upload this image. Click on upload and detect. So here waste type glass has been detected and a bounding box is drawn around that. Now we will check with the other classes. Click on choose file. So now let us upload this object. Here metal has been detected with a 0.85 probability score. Now let us upload one more metal image and see whether it will detect correctly or not. So now let's upload this one. And here metal has been detected. Let us upload other class. We have uploaded cardboard, glass and metal. Now let us upload the trash. So let's upload the plastic and then let us upload the trash. So now let's upload this one. So here plastic has been detected. Let us detect one more plastic. So now let's upload this image. Plastic has been detected. Now we will upload the last class, that is the trash, and see whether the application will correctly detect the trash or not. So let's upload this one. Let's upload this one. Click on open and now click on upload. So your trash has been correctly detected with the 0.92 probability score. Let's upload one more image. So now let us upload this image. Click on open and now upload it. Here trash has been correctly detected. So in this page, just by uploading images to the system, classification algorithms, they will be classifying the waste, and detection models, they will be detecting where that waste is. Now let's check with the graph. So click on graph. Here we have classification graphs. That means algorithms used for classification. Here on x-axis we have accuracy score, and on y-axis we have algorithms used to classify the waste type. And here we have precision score comparison graph. Here we have recall score. Here we have FN score. And here we have detection models, recall and precision graph. Here on x-axis we have recall score, and on y-axis we have precision. Here all the different colors indicate different types of waste types. And this is the F1 confidence curve graph. This is the confusion matrix. This is the precision comparison graph. Here on x-axis we have precision score, and on y-axis we have the algorithm names. And these are the algorithms used to train the model to detect the waste type. And this is the recall score. This is the mean average precision. Here on x-axis we have mean average precision, and on y-axis we have the algorithm names. Now let's click on logout. In this way, we can accurately detect and classify the waste type by using deep learning models and also the YOLO models. So this will help to sort the waste category without manual intervention. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.